and you're here for a talk entitled Abusing XSLT for Practical Attacks. Your speaker is Fernando Arnaboldi.
Thank you. Hello. Thank you for coming today, and thank you, Blackie, for the invitation. My name is Fernando Arnaboldi, and I work as a security consultant and researcher for IOActive. I would like to show you today how XSLT implementations are vulnerable to multiple practical attacks. For that matter, the very first question that I would like to address today would be this one. Why are we talking about XSLT? A couple of years ago, I was working with Ariel Sanchez, a coworker from IOActive, on a penetration test, and he discovered an external entity expansion attack. They're pretty common. We are here this year at Black Hat, we have 2 presentations related to those type of vulnerabilities. So I decided to explore a little bit more about the topic to learn a little bit more about XML, schemas, and XSLT, who somehow all these technologies may work together. The objectives of this talk is to analyze how these weaknesses can be abused. I like the idea of having a presentation where you could have practical things to abuse, and hopefully this will be the case. And you will see how the different implementations can be abused. So whether you are reviewing code, and if you're looking for security issues, from time to time you may come across XSL files, XSLT files, or XML files that are related to XSLT files, which may be vulnerable. Or if you're developing XML or XSLT, that would be directly meant for you. Or eventually, if you're trying to abuse something that is using this type of technologies. The thing about this is that processors are still affected by these flaws. As I was researching for this, I reviewed different programming languages, and for that matter, there are different books that you can use. And when it comes to XSLT, I couldn't find valuable information. So today I will be talking about 5 issues that hopefully will help you to make the confidentiality and the integrity of the applications using this technology a little bit less secure if you're able to get your hands on this. And the good thing is that all the flaws I will be talking today that will be exploited on the implementations, these are how the implementations were created according to the standards, supposedly. So no antivirus will be detecting what we're going to show today. So quickly going through the agenda, I will tell you a little bit how an attacker will be able to use this, how we'll be able to identify who's the target, and then I will go through how numbers may be used either to steal money or to affect the integrity of the information, how random numbers may get the applications insecure, they may be predictable. I will bypass the same origin policy on a web browser using SSLT, and finally I will talk a little bit about informational disclosure through error messages. So briefly, I will start saying about what XSLT does, how we're going to use it to attack the implementations, and how we could eventually identify who's our target in here. So, as I was saying, XSLT is a language that was created along with XML, and is commonly used to transform an XML document. So receive as an input an XML document, it produces as an output a new document, which could be, again, an XML, a text file, or an HTML document. When this was created, they thought that, okay, it would be cool to have the XML data here, and if we have something that transforms the information that is contained on the XML, a programming language, we could have the clients to automatically process the information that is here, and we do not need to do this on the server side. So the first version that was created was XSLT v1. It should be noted that versions in here didn't mean a different thing than the common pieces of software in here. v2 adds more functionality over v1, and v3 does the same over v2. The thing is that XSLT v1 has been the most implemented version. Of course, this is because it has been implemented by v2 and v3 in most scenarios, and also because it is supported by web browsers. And any technology supported by web browsers, it is widely deployed. There are two types of software that was tested for this matter, and that's the server-side processors. This will be the standalone processes that can run from command line, that you can execute it directly to process an XML and XSLT file, or libraries which can be used by different programming languages. You can use either Python and import an XSLT library, or PHP, Ruby, whatever. And then you have the client-side processors. Basically, I focused my efforts on the web browsers, but you have other type of processors available. I grab all the latest versions available, and when it comes to the server-side processors, there are three that I will be focusing today. There would be libxslt developed by GNOME, Ceylon developed by Apache, and Saxon developed by Saxonica. This is the only implementation that is not free, and probably are the guys who take more seriously about XSLT. All these implementations have a standalone version and a library that can be used by programming languages. Again, from this implementation, probably the most widely deployed is libxslt, because that's the version that is being used for Python, PHP, Perl, Ruby, and the standalone processor as well. When it comes to web browsers, all the 5 top web browsers, I tested the latest version that I could get. But let's move on how an attacker could affect all these different implementations through different attack vectors. The first possibility would be an XML or an XHTML document that is using an XSLT to create a new document. This is a common scenario for a server-side processor. You're writing in command line the name of the standalone processor, an XML file, and an XSLT file, and then it will produce a new document. So this is how I started developing XSLT 5 years ago. I receive an initial document XML. I look for the most common language to process this document. And I thought that XSLT could be an alternative, and it's the fastest way to produce a new document when you're having as an input an XML. In here, we are feeding the XSLT processor with the two files. Another approach will be that the XSLT processor will get the XSLT file. This will be in a scenario where the XML document refers to an XSLT document on the header. It says, grab the style sheet that is being stored in this location. This is a common thing when you're trying to exploit an external entity expansion, and you're trying to retrieve an external document or an internal system file to be read. You're requiring an external file that is being used. So in here, we can say the processor, grab this file from me, and then produce the new document. This may be used by web browsers, but probably if you're targeting a web browser and you want the web browser to be sure that it's going to read the XSLT file, you better embed the XSLT along with the XML, and you will have one unique file. And this is better because Chrome doesn't get the files directly if you're trying to use the second attack vector. So this attack vector will have the XML, the XSLT, and the payload all together into one single file. Once that you know how you're going to attack the victim, you may want to know who's going to be your target. So this would be in a scenario where a black hat approach is being taken because you're not reviewing code, you're just trying to get the information without knowing what you have on the other side. So the first alternative would be to see what are the XSLT properties available. There are 3 XSLT properties commonly used. These are the 2 most common, the version and the vendor. Using these syntaxes for XSLT, we can get the version and vendors being used. But We can also rely on JavaScript if you are targeting the web browsers. It would be nonsense not to use it if we are trying to receive a little bit more information of our victims. So for web browsers, we will go through the navigator objects to try to retrieve the information typically stored in a user agent. So once we get all this information, we may create a summary of what are the possibilities for our targets. After each section, I will show you a summary disclosing which are the server-side implementations that I check, which are the client-side implementations, and what is the information basically that we are able to get, or the errors that we are able to exploit. We can see here that the first column shows the names of the different implementations. We have Salem, two for Salem, a C implementation, a Java implementation, Saxon, XSLT Proc, that's the standalone parser for the libXSLT implementation, PHP, Python, Perl, Ruby, Safari, Opera, Chrome, Firefox, and Internet Explorer. All of them are using XSLT v1, except for Saxon, who natively uses XSLT v2, even though supports XSLT v1. And the vendor, well, the first two are related to Apache. The third one, Saxon, is from Saxonica. And then you will notice there is a bunch of libXSLT that range from the server-side implementation to the client-side implementation. This is because the library is being used by both sides of the different pieces of software. That being said, not always the implementations behave on the very same way. I would like to start speaking about the fun things, how we're going to try to take advantage of the numbers on the XSLT implementations. When we're talking about numbers, I'm talking about calculations, floating point numbers, integers, what you do on any programming language, nothing else than that. So numbers will be present always in client-side and on server-side processors. Either you're doing a calculation or you're storing information, you're moving any type of number, you have to consider that the integrity could be affected. The problem I initially found it with the real numbers, floating point numbers. This is a common thing. This is not new for the computer security industry, that there might be difficult, the precision to be exact when you're dealing with very small numbers. The problem is that also happens also with large numbers. So you have the problem on both sides of the equation here. So it is a little bit confusing when you're trying to make a simple calculation, a trivial calculation, and that may not work as you expect it to be. So I initially tried to make a simple thing, defining a style sheet where I will try to solve a simple calculation. Every XSLT file will have this structure. You can recognize an XSLT because we'll have this. It may or may not have the first line where it says that this is an XML thing. It will have the style sheet saying that, okay, I'm a style sheet, this is the version that I'm using. It may or may not have the output that it's trying to produce. And of course, it will close the tag at the end, just like we would use it on HTML. And on the middle, I will have that I will try to do this calculation, 0.2 plus 0.1 minus 0.3. The result of that should be 0. The problem is that programming languages are somehow unable to fully calculate this, and this is because decimals are not represented in the same way in binary notation. For example, 0.1 on binary notation is an infinitesimal number that is difficult to be represented. So sometime, at any given moment, you need to put an end to that. And whenever you're doing that, you don't have the exact number. So programming languages, what they do is they round up numbers. So this calculation should round up to number 0. That's the scenario for Opera and Chrome. But for the rest, all of them will say it is almost 0. It is almost this number. And this goes for all of them. Firefox, Safari, Internet Explorer, Ceylan, Saxon, PHP, whatever. So the problem is across all the different implementations in here. So this is cool. I found that. So I show this to my colleagues and I say, listen, look what I found. And they said to me, okay, this is nice, but what can I do with it? And I say, okay. So last week, I was trying to provide a valid example of this. So XSLT is good for parsing XML data, but it's not good for building an entire application. But since this problem is present in all programming languages, I decided to create a very small implementation on JavaScript. What I was planning to do was to grab one of those decimals, grab the remainders that you were seeing, and put it somewhere else. So I created I don't know how bank applications work, but I decided to create my own bank application because for obvious reasons I cannot do this with my bank, because if it works I would be in problem. So I created a bank application which has 2 accounts. On account number 0, it has $1 million. On account number 1, it has $0. The total balance of my bank is $1 million. The thing is, I will try to grab the smallest possible number, make it as high as possible, but without making the $1 million account smaller than what it is, and move that number to the second account. And hopefully what I will be able to do will be to increase the amount in the second account, but the first account will never be decreased. What I did basically was a function that receives a very small number. It decreases the account number 0 and increases the account number 1. But since the value on the account number 0 is so low, it will never decrease. So let's move to a practical demo of this. First, I will try to find which is the largest smaller number possible to be transferred that will not decrease my $1 million account. This is the first part of the program. Once that it finds that number, this is the number 0 followed by a comma and 11 zeros, it will start to transfer that amount to my second account. That's my profit account. And by the end of the day, I will be making $1,200 having this running all day long. This is doing millions of transfers from one account to the other. But let's talk about integers. So I did something very basic in here. I define an XML which has 5 values. 5 are in exponential notation and 5 are not. So what are they? This is a number 1 followed by a bunch of zeros. What I was trying to see in here is how processors may inject errors in here. So for that matter, what I'm trying to do first is to print the original value and then print the XSLT representation of that. This function format number, what it does is it has a comma as it has been written in there every 3 positions, so numbers will be more readable. So this is what you're expecting to see when you're running this, and Saxon did it. So first you have the number, the original number, 1E22, that's the number 1 followed by 22 zeros, and that's what you get. But since we're again working with numbers that XSLT processor may not be able to use, sometimes they may have problems. Internet Explorer and Firefox did what I was expecting them to do, but they were not able to show the exponential notation. But libXSLT was also vulnerable to this, was not able to round up, and it started to show weird things at the end. So this is affecting a few of the implementations. Things got funnier when I was trying to move to Ceylan, where, where one of the values was missing just for one of the numbers. And Salem for C, I don't know. I just don't know. So there's a justification for this, also for the floating point numbers. Programming languages only can handle a certain amount of precision, and that's it. Nevertheless, implementations adopted different solutions. They do not all behave the very same way. So when I was reporting this, I was not happy with what I was seeing, even though it is supported. When I'm doing a calculation, I'm expected a certain calculation to be the same as I'm doing on a piece of paper. In particular, when it's something so basic. I'm not trying to calculate p in here. So as I was sharing this with the security teams, I was told that the very first thing would be to read Wikipedia to see how the floating point numbers work. And that was interesting. Then I was referenced another specification, and not the specification that I was checking. That was really interesting too. And the thing was more fun when JavaScript was referenced as the explanation of why this was happening. Okay, let's move on. And let's see that, okay, errors are everywhere. We had a similar table for the floating point things. But now, we don't have decimals. We want integers. I will try to do a similar thing as I did before. But for this matter, I created a cryptocurrency application. Being that said, I know nothing about cryptocurrencies. I created what I believe is a normal cryptocurrency application, again with 2 accounts. I bought $1,100,000 of coins. Now I have a lot of coins of a coin named fake coin. Again, what I will try to do is I will buy a number 1 followed by 17 zeros of coins of this fake coin, and I will subtract the number 1 from this account. I will transfer 1 coin from the account number 0 to the account number 1. Since it is such a large number, the account number 0 will never be diminished in amount. If I will subtract the number 2, it will get diminished. But number 1 doesn't affect the first account. So you will notice that the application works like the previous application. First, it tries to determine the largest possible amount that will not get noticed when it is missing. And then it will try to move as much coins as possible to try to get the largest amount of money. V8 is the Google Chrome implementation of JavaScript. So in here, I have a little bit more profit at the end of the day. I'm making $2,300 per day, making a lot of transactions. And as you can see, the account number 1 is increasing the overall value for the application. He believes that he has more money than it actually has, but it doesn't. It just doesn't. The thing is that the account number 0 was never decreased. So let's talk about random numbers. This is something that is on server side. We will not see this on client side processors. As a general rule, when we're talking about random numbers, we should know that not any random number generator should be used for cryptographic purposes. This is a very basic thing when it comes to programming. So random numbers in XSLT may behave a little bit different. First of all, it is not part of the original specification of XSLT. This is something that is on the extended specification. But being a developer myself, I believe that random numbers is a very basic thing from any programming languages. And it's a very basic thing used on any XSLT implementation. So we are using a function that is called random, and it should return a number between 0 and 1. And as most random number implementations, you would expect that this number, it doesn't have any pattern. You're not able to know where this number came from, or to know what will be the next number, for that matter. So normally we may use pseudo-random numbers for simple things. For example, pick a color, pick a name, something like that. And for that, we use random implementations which are do not have a lot of security, but they may be good for what you were trying to use them. But we may rely on cryptographically secure pseudo-random numbers when it comes to sensitive stuff. If we're trying to hatch something, if we're trying to generate a new password, we require, when it comes to Python, system random instead of random. It will grab a better entropy, will be less predictable. So half of the implementation that I was analyzing were open source, so you're able to see how the code looks like when it comes to the random implementations. And as you can see, all of the implementations are using pseudo-random number generators. That's not bad per se. The thing is that if you see someone who's using a pseudo-random number in XSLT, it is using a pseudo-random number implementation and not a cryptographically secure random number. So we have three types of functions: ran, sran, and random. They all return pseudo-random number values. When I was analyzing what was the implication of this, I thought that the man page of sran said it all. So the thing is that as long as the random values are not used for sensitive things, it's okay. If they are using for sensitive things, and if they are using a certain implementation, things get a little bit more interesting. So when you don't have an initialization vector on a cryptographic pseudo-random number generator, you may always get the very same number. And that's, of course, ridiculous if you're dealing with a random number. That's not random anymore. And the meaning of this is that you will know which numbers will be generated. So you will always like your random function to have the initialization value, and it will be good for your security. So let's review again how the implementations were relying on the initialization vector. We have in here, again, the same code that we saw before, and what we will notice in here is that libxslt, the most widely deployed version, is not using NIV. The fun thing about this is that they know this. For the past 9 years, they know this. I don't know why they keep this the way it is. But I will show you the implication of having this the way it is. So again, we have a style sheet. As you can see, again, we have the style sheet, open tag at the beginning, we're closing at the end, and we have a value of which will be triggered, which will get the math random function result, which should be, as we saw before, a number between 0 and 1. So this will be the result that we will be obtaining if we are executing this program on a standalone version. As you can see, there will be the same result over and over again. It doesn't matter how many times you write this program. It will always give you that number, 7.8, blah, blah, blah. Okay. This will not be the same if you are running the library, because if you're running the library, once that it has been executed for the very first time, you will get a new number the second time. So what I did is I wrote, I created 2 terminals on my computer, and I created 2 executions in Python. And I was trying to correlate how Python behaves and how the random function from Python behaves versus how the XSLT random function behaves. So the very first thing that I did was to get a random number from Python. And this is the random basic function. This is not the secure random thing. And in here we're getting 2 different results. We have one result on the left and a different result on the right. But when it comes to libxslt, we get that number. Remember the previous number? This is the same number. If we try to get a random number again with Python, we'll get again different numbers. We have 4 different numbers from Python. And when it comes to libxslt, we're getting the same random number on both sides of the terminal, 0.13, What this means is that execution, after execution, the libxSLT random function will produce the same pattern of results. So if the random function is being used on a cryptographic block cipher, you can know what will be the next cipher because you always know which is the next number that's going to be used by this implementation. So without having a number that is changing like the time, when the functions are being called, the same numbers will be generated. So in case the random function is being used for sensitive information, the results may not be good. You may get what they were trying to hide. We were talking about server-side implementations. Let's go to the client-side implementation. Let's violate the same origin policy. So again, this is something that is client-side. This is basically something that says the browser should keep on the very same web page and not retrieve information from nowhere else. And that's how web browsers are supposed to work. If they didn't work this way, we could be able to read information, private information from other websites. At least I don't like that idea. The same origin policy is a basic policy for web browsers. And that says that when you have a URL, you will have the scheme at the very beginning, the HTTP or HTTPS protocol. You will have the host, example.com, blackhat.com. And you may have the port stated or not. It would be port 80, port 443, whatever. The moment that one of these three things is being changed, it is not the same origin, and the information shouldn't be accessed by the web browsers. Because web pages should be isolated from each other. They should be like different rooms in a house. They shouldn't communicate at all if any of these three things are changed. Normally, when you're trying to abuse this, you may rely on JavaScript, but that's not the only programming language that is capable of abusing the same origin policy. This is a typically valid scenario. You have the example.com application running on HTTP on the port 80, and it's trying to access a second web page that is being hosted on the same web server. The web browser will say, it's okay, go ahead, I trust you, you have the same scheme, the same host, the same port, you are good to go. You know what? You can access all the web pages on this web server if you have the privilege. A different thing would be when it comes to when you're altering the scheme, the host, or the port. In here, the web browser will say, no way I will let you see. I will use the same credentials that we used before. You will not use the same cookie in here. You will not use the same cookie in here if you're changing the host name. And definitely you're not doing this if you're changing the port. So, again, when you are on the same domain, on the same port, on the same scheme, that's when you're saying your cookies. That's when you're sending private headers related to that website. So what I thought was, what if I don't care about this? What if I try to do something with this? So there is only one function that would read files and would eventually be capable of doing this. That's the document function. What it does, it grabs an XML document and tries to parse what's inside, and then you do something. This is a common way in an XSLT to manipulate a document. It should be noted that since we're dealing with web browsers, we normally will see an XHTML document. XHTML document, it is a common HTML document, but the thing is that it is more strict. Sometimes in HTML we may miss one of the tags and the application will still work. In XHTML, it is very strict. It wouldn't allow that. But the thing is that an XHTML document will also allow you an XSLT document to be embedded. So certain servers have migrated their configurations to XHTML to be compliant, to have more specific documents, and they will render exactly as they should render. There will be no missing tags. So once we are retrieving the document, we may want to manipulate the information. And for that, there are two functions that will be used after accessing a document. That will be copy of and value of. For practical reasons, they will show the information that is being stored. So I mentioned that XHTML thing. So I look for a XHTML website. Bing.com uses that. So I have credentials for that. If I open my web browser, you will see that my name will be in the upper right corner. That's a normal behavior of Bing.com. The lower portion of this screenshot will show you that my name is on this tag named ID_n, and that's where my name is. So the only origin possible that is able to access this information is, I don't remember if it was an HTTP or HTTPS, probably it was an HTTPS, Bing.com on the port 443. So let's try to access this. So we saw that we need a document function to access a web page. So let's access Bing.com with that. Then we will manipulate that information. We'll get it with, in here we will use copy of. Since I'm better with JavaScript than with XSLT, once that I have that in place, I will get the ID_n value that holds my name, and I will print it. So I will show you a short demo where at first you will see Safari being open, and then I will open the file that is on the desktop. That file will try to access my Bing.com information using the cookie that is being sent to Bing, but instead of accessing the correct scheme, it will try to access a file that is locally stored on my computer. There you can see my name in the upper right corner. And there I'm accessing the file that is able to retrieve my name and print it over there. What you see in the text area over that is some code of the Bing.com that is being retrieved when I did the document thing. So I tried this across different web browsers. I was only able to do it on Safari. I tried on Internet Explorer, but Internet Explorer was not sending the cookie, and the other browsers didn't do anything with this. So the last thing that I would like to talk about is how errors may help you to get passwords. So this is something that you may get on server side and on client side. The thing is that if you're trying to retrieve information, it is better to do it on server side, in particular because all web browsers we have the restriction that will not be able to go below the place where you're trying to access in that file, the directory. Server-side processors will allow that. So the fun thing about this is that when an external entity expansion is being used, you're using a function that allows a file to be read. But in here we have no functions to read those files. Those functions were added on XSLT v2, which is not supported by the majority of these implementations. It is not supported by web browsers, and it's not supported by libxSLT, you name it. So we hear multiple times this is not possible. But what if we try? What if we force the applications to try to read this? So again, we talked about document a moment ago. We were trying to access a different origin. But in here, we're trying to access something that is not possible. So I will try to use any possible function available. I will try to use include and import, which are meant for XSLT. Since we're processing something that we cannot process theoretically, we may try to use whatever we have it. So I created a simple text file with 3 lines. And here you can see how the file is created and what are the contents. When you're reading the specification, you will notice that the behavior should be that there is either an error being shown to the end user, where you will see that the content is not allowed. 3 implementations said this. Or you're either showing an empty node set. That means an empty XML document. So that's okay. But libxslt doesn't do that. libxslt will show you the first line of the file. And this is where it gets interesting. If you have only one line from one file, and you're able to control either the XML or the XSLT, you could try to get valuable information if you're only able to read that one line. So there are specific files which will be interesting to access when you have access to this. Clearly, etc. password that holds the root password. Even better, if you have root access, go for the etc. shadow. Root password is being always stored on the very first line. HT password puts password directly on the very first line. And again, you have, for example, a database storing passwords on the very first line. So this is what you will get if you're trying to read a teacher password when using XSLT proc. There you have an encrypted password. So somehow, XSLT could be as fun as an external entity expansion, because you could try to use other languages. If someone is using a PHP with a libxslt library, they could trick someone to use an XSLT file that will try to access, again, a password, an encrypted password. Or even better, if the victim is running this as root, let's go for the etc. shadow. In here, I'm showing an example using Ruby, retrieving the very first line of the etc. shadow. That's where the root password is. So I'm showing here only the server-side implementations, and you will notice the weird thing that Ruby doesn't have the document thing. But you have a lot of possibilities over there if you're trying to read a file through errors. So basically, if you're letting someone control the XML or the XSLT, you will be compromising the security on any given way. Sometimes the confidentiality and the integrity could also be exposed depending on how they have created this. And finally, my recommendation would be for you to check the code, or someone else's code, for that matter, if you want to have an idea what would be the possibilities. Someone has any questions?
What if you're trying to read a very large file like /dev random, /dev random?
The question is, what if you're trying to read a very large file like dev random? It will only read the very first 80 characters. So it will stop immediately after there, and it will show you that. Any other question? Yes? I reported all the vulnerabilities. No one has been fixed. So thank you very much for coming. I will be here for a while if you want to ask something else. Thank you.